Hello everyone, welcome to Poesy's e-learning and certification services. This is a new video session in the MQTT series, and in this session you will learn how to build a publisher application in Python language. PubSub Architecture defines two types of clients, publisher and subscriber. A publisher can send MQTT messages to a broker. This process is called publish. For example, an IoT sensor device can publish acquired sensor data. A subscriber client can receive messages published by publisher client. An MQTT broker's role is to receive messages from the publisher and forward them to the interested subscriber or more than one subscriber. PAHO Python MQTT library provides a simple function to publish on a topic on the broker. Syntax is here. This function takes the following arguments. First is topic, the topic that the message should be published on. Payload, the actual message to send. If not given, set to none, a zero length message will be used. QoS or quality of service level. The quality of service level to use, default value is 0. Retain flag. If set to true, the message will be set as the last known good retained message for the topic. Default value is false. A publish event means when the message has been sent to the broker, an onPublish callback will be generated. Syntax of callback function is here. It takes three arguments. Client means client object calling publish method. User data, user defined data, normally not used. MID value, message ID value to check that a particular message has been published or not. So in the next step, we are going to use publish method and onPublish callback function to write our publisher code. So let's get started. I have publisher code on my screen. Let me walk you through this code line by line. The first line is import statement. We are importing PAHO MQTT client is MQTT. Then in the next step, we are importing sleep from time module. Next, we have three callback functions. First one is onConnect. This callback will print connection return result and then return code sent by broker as a response to connect request. OnDisconnect callback is going to print a message disconnected and then result code sent by broker as a response to disconnect request. OnPublish, as explained earlier, is the callback that is generated when message is delivered to the broker. Here we are going to print message ID just to verify that the message published has been delivered successfully to the broker or not. In the next step, we are creating a MQTT client by calling client constructor from PAHO Python library. In the next step, we are attaching callback functions to this client created here. Post that, we are sending connect request. And since our broker is running on localhost. We are using IP address of the local host. Post connection establishment, we are starting the loop to handle send and receive events. After that, we are calling publish method to publish a simple message hello on this topic IoT/test. After publishing the message, we are sending a disconnect request to broker, and then we are stopping the loop. So this is a simple publisher code. It's going to publish a message hello on IoT/test topic just once. I also have a subscriber application written in Python. We created this in one of the previous sessions. In this subscriber application, I'm using same modules. I have three callback functions: on connect, on disconnect, and on message. On connect and on disconnect, they will do same thing what they were doing in the publisher code. Here, on message is a different callback function. On message is called as a result of message reception event. Inside on message, we are going to print received message. Suppose that here in this line, a MQTT client is created. These three lines are written to attach callback functions to this client created here. This line is to send connect request to same broker running on localhost, and in the next step, we are subscribing to IoT/test topic to receive any message published by a publisher on broker on this topic IoT/test. Here we are using loop underscore forever loop function. This function is used when you want to keep your client waiting for the messages indefinitely. Loop forever also handles reconnects. So this is our subscriber code. I will run my subscriber code in a command terminal window and publisher code in IDLE window. Let me show you how. So to test these codes, first we'll run broker in a terminal window. Command is mosquito-v. As you can see here, broker is running. In the next step, I'm going to run subscriber code in this terminal window. This is my subscriber application. As you can see here, subscriber has successfully connected to broker. Broker has accepted connection request as well as subscription request and has also sent subscription acknowledgement to this subscriber client. Let us go to our publisher code now. I'll run publisher code from here. Look at the messages. A message with ID 1 has been published. Connection return result 0. 0 means the operation was successful. And then disconnected result code 0. This connection was also successful. So our publisher code published a message with ID 1 and then it disconnected from the broker. Let us go to subscriber window now. In the subscriber window, we find these messages. Connection return result 0. So this was the message printed when connection was established. And then here we have received message hello. Let us look at the broker window. So here we have this messages printed by broker. Broker received a connection request from publisher. It sent a connection acknowledgement. Then it received a publish request with topic name IoT/test and a message of length 5 bytes. 5 bytes means 5 characters of this message hello. After receiving publish, here in this step, broker sent this message or broker published received message on subscriber and then it received disconnect from the publisher and then finally publisher got disconnected. So the message published by publisher on broker has been published by broker on subscriber. So our message has completed round trip. I hope you enjoyed it. We'll continue learning MQTT. So stay tuned, stay in touch, happy learning.